So our analysis is looking at the photovoltaic industry at a global scale, and we're including both kind of residential rooftop installations as well as commercial on top of shopping centres, as well as utility scale installations. What we're looking at is the energetic cost of both manufacturing and installing these PV systems. The total energy input, so from things like coal and natural gas in order to produce these PV systems and support the growth of the PV industry, photovoltaics industry. So currently over 90% of the PV market is crystalline silicon. So the process is you extract silica, you basically melt this rock and raise the temperature up to 2000 degrees. You then have to remelt it in order to form the crystalline structure, and then you saw it up into these thin wafers. You then print contacts onto the wafers and form them into the cells, and then put those together in a module together with an aluminium frame and glass fronting. Newer forms of photovoltaics can be produced in a printing process whereby the absorbent material is screen printed, and this is done on roll-to-roll processes rather than batch processes as silicon is produced. But we were interested in whether, because the photovoltaics industry is growing so rapidly, then maybe it was consuming more electricity than it was producing on an annual basis. And the results from our analysis suggest that the PV industry is currently at the threshold. So it either became a net electricity producer around 2010, or in a worst case scenario, kind of will be within the next couple of years. There's a lot of debate at the moment about the effectiveness of financial subsidies for the photovoltaics industry. And I think that this paper shows that actually the industry is making positive strides, and it's even despite its fantastically fast growth rate, it's still producing it, or it's just about to start producing a net energy benefit to society.